Hey guys, I want to make a quick video for you about factoring polynomials. All right, so I have here the notes that's going to be online, and there are 8 total questions here. I'm going to pretty much talk through all 8. All right, so you can get a kind of a good idea to see what am I doing for each of these problems. Okay, and we're going to start off with some easier ones, going to a little more difficult as we go through. Okay, so for 1 and 2, these are pretty basic factoring problems that you did before. Okay, number 1 is just factoring a regular quadratic, x squared plus 7x plus 10. Okay, that's pretty standard. We just want to find two numbers, multiply to 10, add to 7. So two numbers multiplied to your c term, add to give you your b term. Okay, so two numbers multiply to 10 and add to 7 are 5 and 2. Okay, so once we know 5 and 2 are the two magic numbers, we can rewrite it as x plus 5 times x plus 2. Okay, this is not solving. Okay, this is just strictly factoring. Okay, so if you're just factoring, we're done. Okay, you don't have to solve what x is equal to. Okay, that would be a little bit too much extra work. Okay, number 2, similar thing, but before we can start doing any factoring here, the normal quadratic factoring at least, we have x cubed minus 7x squared plus 10x equals 0. Okay, so here we have a GCF. Okay, all three terms contain 1x. So what I'm going to do is I'm going to take out an x first. Okay, that's this middle step is here. So I removed an x from all the pieces. That's going to leave you with x squared minus 7x plus 10. Well, this is just a regular quadratic. Two numbers multiplied to 10. It's a positive 10. Add to give you a negative 7 are negative 5 and negative 2. Okay, that's what these two numbers are here. Well, I can just write this whole thing as x. Okay, that's still one of my factors. That's not going to change. Now, instead of having x squared minus 7x plus 10, I have it rewritten as x minus 5 times x minus 2, and we're done. Okay, so these first two are just a little bit of a standard quadratic problem to factor, and this one has a GCF. So those ones we dealt with before, we've been solving them, all that fun stuff, okay? Now we get into ones that are a little bit more challenging, at least that's what it seems. Okay, so number 3, number 4, we have 4 total terms. Okay, there's 4 different pieces. So for 3, we have x cubed minus 5x squared minus 5x plus 25 equals 0, okay? I want to factor this thing, okay? Well, the only way we can factor this is by using something called factoring by grouping. Okay, and what I'm going to do is I'm going to take the first two terms, in this case x cubed minus 5x squared, and I'm going to group them together. Notice here in the second line that I wrote, it's the same thing except I put parentheses around it. Okay, that's my first group. Okay, so I'm going to take x cubed minus 5x squared and put it in a group. Okay, that's what's happening here. Now, look at my last two terms. I have negative 5x plus 25. That's going to form my second group. So another pair of parentheses, I'm going to have negative 5x plus 25. Okay, that's my second group. Now notice that between the two groups we have a addition sign here. Okay, we're adding these together. Okay, so I just took something and I chopped it in half, right? If you had $2, like $2 bills, right? If I just took one and put it on the left and one put it on the right, you still have $2, just one's on the left side and one's on the right side. Okay, and if I add them together, I get 2. Okay, it's the same idea. Now, the goal here by grouping is instead of looking at one big giant crazy problem, we kind of chop it in half and deal with the halves separately. So if I look at x cubed minus 5x squared, okay, that's a portion here that I made, one of my groups. I try to factor that group only. So between x cubed and negative 5x squared, the only things they have in common are x, and in fact, two of them, right? I have 2 x's here, 3 x's here, so I should be able to take 2 away from both. That's where we get to this point here. Okay, if I take x squared out from both, I get x squared times x minus 5 in the parentheses. Okay, then I go to my second group. I'm going to do the same exact thing. I want to try to factor it. So negative 5x plus 25. Okay, negative 5 and 25 are both divisible by 5. Okay, so I'm going to factor out a negative 5 from both. Okay, if there's a negative sign in the front here, you're always factoring a negative. Okay, that's a rule of thumb. So I'm going to take negative 5 from both pieces. Okay, so I put a negative 5 on the outside. That's going to leave me with x minus 5 in the parentheses. Now, if everything goes well, we should have the same thing in both parentheses. Okay, this is kind of the most important step here when it comes to the factoring by grouping. Okay, from setting up the two groups and factoring each one individually, we should get the same thing in the first group and the second group after factoring. Okay, in this case, they're both x minus 5, which means x minus 5 is a factor. Okay, that's why it's written here in the answer. Now, What do we do with the things in front? Well, we have x squared in the front of the first piece, minus 5 in the front of the other piece. Well, those two form my second factor. So I get x squared minus 5 as my second. This is pretty much just factoring out x minus 5, technically. But pretty much the way I like to do it is I take my insides, write them once, take the outsides, combine them together, and bam, there's your factor. Okay, try not to make it as overly complicated as possible. Okay, so that's going to be an example of factoring by grouping. Okay, so we have factoring a regular quadratic. That's 1 and 2. 3 and 4 is factoring by grouping. 4 is a little special because I included a GCF. So if you notice here, all these have an x, right? X to the fourth minus 4x cubed minus 2x squared plus 8x all contain 1x. So I can factor out an x here, and I'm left with something that I can then try to factor by grouping, which, I took the first two pieces, I grouped those, the factors here, took the second two pieces, grouped those, and factored here. Okay, so I kind of left out the middle step here. So this first step we did for 3, I excluded it for number 4. Okay, but that's what's happening here. All right, then we go on to number 5 and 6. 5 and 6 are a little special, okay, because they look exactly like 1 and 2, except I have x to the fourth as my largest power. So this is a quartic, okay? So this first one, 5 here, this is a quartic binomial. 6, this is a quartic trinomial, okay? I'll talk what happens through both of these, okay? Now, for number 5, it's x to the fourth minus 81. All right, so the way we're going to factor this is pretty much the same way as we factor any regular quadratic, right? The way we did those is, find two numbers and multiply to c, add a b. But there's a little special case here because there is no b term, okay? So this is called a difference of squares. Okay, if I take the square root of x to the fourth, I get x squared. The square root of 81 is 9. So what I can do is I can rewrite it as x squared minus 9 and x squared plus 9 equals 0. Okay, so here we go. I factored it. Now, the only problem with quartics you have to be careful with is sometimes you're left with a factor that can be factored again. So x squared minus 9. Well, guess what? The square root of x squared is x. The square root of 9 is 3. So I can do the difference of squares again and get x minus 3, x plus 3. Okay, so once I factor the first time, I'm left with a term that I can then factor again. Okay, so I can break this down to be x minus 3, x plus 3. Okay, since this is a plus, this is not a difference, this is a sum. So I can't really do the difference of squares. So I'm stuck with x squared plus 9. Okay, whenever you have a plus, can't do anything to factor if it's a quadratic here. If it's a minus, you have a chance, but it's not a guarantee. It has to be a perfect square. Okay, a good example of this is going to be for number 6. All right, so number 6 is another quartic example. Okay, quartic trinomial in this case. I have x to the fourth minus 9x squared plus 20 equals 0. All right, now from here, in order to factor, I'm doing this just like a regular old quadratic equation. Find two numbers and multiply to a positive 20, but add to give you negative 9. Okay, so if you sit there and think about it a little bit, maybe type some numbers in a calculator, however you want to do it. Negative 4 and negative 5 add to give you negative 9, but when you multiply them, you get a 20. Okay, so what's going to happen is just like before, I'm going to get x minus 4, x minus 5, but notice I don't just use a regular x, I'm not using a x squared. That's because x squared times x squared is x to the fourth. Okay, so if I have a power of 4, I get x squares in both my terms, okay, versus, just x squared, right, for number 1, we get an x in both pieces. Okay, so x squares give me 2 x's, x to the fourth give me 2 x squareds. Okay, now, most people will be like, all right, cool, there's my answer, but that's not the only thing I can do here. Okay, I have to take x squared minus 4 and reduce that because this is, again, like number 5, a difference of squares. Because the square root of 4 is 2, square root of x squared is x. So I can break this down to x plus 2 times x minus 2, or I can say x minus 2 times x plus 2. It doesn't matter the order, okay, but I do get both these pieces. Now, if you look over here, I didn't reduce x squared minus 5. And a lot of people see the minus and automatically try to factor it just because, this is usually when people finally realize about the difference of squares. But 5 is not a perfect square, right? 4 is, 5's not. Okay, if it was 9, it'd be fine. 16 would be okay. 25 would be fantastic. But 5 is not going to work. Okay, so that's going to stay the same. Okay, the only time you can reduce a factor here into these two parts if it's a difference of squares, meaning that this number here has to be a perfect square, or this number here has to be a perfect square. Okay, if it's a power of 2 or any even power, it will work. Okay, so that's going to be your quartic trinomial example. Okay, so those are the first 6 here. We have regular factoring, quadratics. Okay, then we have factoring by grouping. Okay, that's what this is called. Okay, 3 and 4 are factoring by grouping. 5 and 6 are factoring quartics. That's what I refer to. These are factoring quartics. And then 7 and 8 are small looking problems, but they require a formula. These are probably, if you know the formula, one of the more easier ones to factor because you're just using an equation every time. Okay, and these are 2 examples, either the sum or difference of cubes. Okay, over here on the right, I have the equations. Okay, so if I have a cubed plus b cubed, it's going to be equal to, if I factor it, a plus b times a squared minus ab plus b squared. Okay, the difference of cubes is the same thing, but you have a minus sign in between. So it's a cubed minus b cubed. And what that does, it changes your factor to be a minus b times a squared plus ab plus b squared. Okay, so these are the 2 things you're going to use. Okay, so if you see 2 perfect cubes and they're being added, this is how you're always going to write it. Okay, if you have 2 perfect cubes being subtracted, this is how you're always going to write it. Okay, now here's how it works. Look at 7, x cubed. Well, that kind of looks like a cubed, right? Do we have 8? Well, that doesn't really look like b squared, but guess what? And this should be a cube root, by the way, not just a square root. The cube root of 8 is 2, right? Which means 2 cubed is 8. So what you could technically do is rewrite 8 to be 2 to the third. Well, guess what? That looks like b to the third. Okay, so what we do is once you identify this as a sum of cubes, okay, this is a sum of cubes, what you're going to do is rewrite it using this equation. All right, so we're going to use x for a and 2 for b. So I should have x plus 2, that's our first part here. Then using the formula, it's a squared, but we're saying a is x. So we're going to get x squared here. Okay, so it's x squared here minus a times b. Well, a is x, b is 2, so that's really just minus 2x. And then we add whatever b squared is. Well, b is 2. 2 squared is 4. Okay, here you go, factored. Okay, the hard part about these is memorizing these equations. Okay, you won't have them available to you all the time. So being able to memorize these is kind of like, the challenge. Okay, if you don't know what it is, you can't factor it. Okay, so that's kind of the one thing you have to try to be careful with. Okay, and for 8, I threw in a GCF here. So if x to the 4th plus 125x equals 0, well, guess what? They both have an x, so x comes on the outside. Okay, what we're left with is something very similar to 7. We have to see, okay, well, what's the cube root of 125? Well, that's going to be 5. So in this case, x is a, b is 5. And this is a sum, so we're going to use the addition one again, okay? We only use the subtraction one whenever there's subtraction in the original problem. So what we're going to do now is we're going to do pretty much the same thing we did for 7. Okay, x hangs on the outside, not going to do anything with that. Okay, so I can rewrite this as x plus 5, because x is a, b is 5, so I get x plus 5, times x squared minus 5x plus 25. Okay, that's using this equation over here, okay, the sum of cubes. Okay, so depending on there's addition, use the sum of cubes, and there's subtraction, use the difference of cubes. And that's pretty much it. Okay, so these are all the different types of factoring. Okay, this is available to you to look at and kind of ponder and look over. Okay, I want to make this video to give you a little bit more explanation, because as you see, there are some parts here. This is usually notes I use when I'm on the board. So this doesn't always contain everything that I normally say and do or write on the board. So I want to try to give you that same experience by making this video for you. Okay, if you have any questions, don't hesitate to give me a shout out and ask me what's going on. Okay, send me an email or whatever. Okay, hope you guys are staying safe and enjoying your days. Okay, have a good one. See ya.